Now, good morning learners and welcome to my lesson 3, where today I'll be discussing about the modern periodic table. In my previous lesson 2, I didn't mention about the relative atomic masses, especially of isotopes, and I think we were able to mention here that given the relative abundances, maybe in percentage or ratios, you should be able to work out the relative atomic mass. Now, maybe we mention about this periodic table, maybe I can take you back a little bit and give you maybe a small history about the periodic table. Now, it's important maybe to mention here that one of the key things that the chemists have been doing here is actually to try and study the properties of elements. Now, in an attempt maybe to study these properties, there was a need, and there has been a need to classify my elements here, maybe on the properties, so that maybe the elements with a property, they are arranged together, so that we can have an easy study. And therefore, in the course of so doing here, we've had two chemists here who really attempted to do this and brought about the modern periodic table. One of those chemists here happens to be Mendeleev. Now, this Mendeleev, the Mendeleev's periodic table. He came up with a periodic table here, and with the Mendeleev's here, he noted that the properties of elements was a periodic function of the relative atomic masses. And therefore, what he would basically do here, he would try to arrange the elements in order of their relative atomic masses. For example, in an ascending order. And he would actually realize, according to his law here, that at a certain point the properties would repeat themselves. But there are a few challenges here on arranging with relative atomic masses here, and the challenge was some of these elements would have the same relative atomic masses. I want you to think about an example of something like calcium. Look at something like calcium. The relative atomic mass of calcium is 40. That of argon is again 40. You can see that. So if we were to think about this here, then arranging them or putting them maybe in a periodic table would have been an issue. And therefore, further researches were made, and we had another gentleman here called Henry, a professor, who was able actually to now bring about the issue of atomic numbers. Now, the issue of atomic numbers, arranging them in the form of atomic numbers, this would eliminate the problem of isotopes. It would also eliminate the idea or the problem of some of these elements here having the same mass number, but of course different atomic numbers, and so that all would actually fit, in my periodic table. Now, these guys actually now brought us to the modern periodic table. They brought us to what we call the modern periodic table. Now, as far as modern periodic table is concerned here, this modern periodic table here will have columns, of course. We have vertical columns, as you can see here, and there are about 18 of them. But I'm going to talk about the 8 major ones, because this part here that I've left here, which we are calling the block D here, we are also going to have about 10. We're going to have 10 columns. This one will be discussed further in your further chemistry here. But the main ones here, I'm going to have about 8 vertical columns. Now, these vertical columns, we call them groups. Get note of that. We actually call them groups. And these groups here will be named using Roman numbers. Therefore, I'm going to have group 1. I'm going to have group 2. I'll jump here, and I'm going to have group 3. I'm going to have group 4. I'll have group 5. I'm going to have group 6. I'm going to have group 7. I'm going to have group 0. Group 0, or what maybe we would call group 8, but group 0. That's what we are talking about. Now, the other thing here about the periodic table here, periodic table will also have the rows. It's going to have the horizontal rows. This is the first row here, the second row, the third row, the fourth row, and so on and so forth. Now, in this periodic table here, we are going to have, the modern periodic table here, have 7 rows, or what we call 7 periods. You're going to have 7 periods. Now, the first row here, the first row will be called period 1. Period 1. Period 1. Now, the second row here will be period 2. Period 2. The third one, of course, will be period 3. We are going to have period 4, period 5, period 6, and period 7. Period 7. That's what we're talking about. Therefore, these are periods now. We're going to call them periods, and this will be called groups. I've just used G to represent the group. I've just used G here to represent the group here. Now, maybe besides the columns, and maybe the rows here, we're also talking about the elements in the D block. That is between the main group 2 here. I've called this one's main. I've called them main groups here. Now we are going to have here, I'm going to have some elements between group 2 and group 3 here, and these ones here, these ones here, I'm going to call them transition elements. Look at that. Transition elements. Transition elements. Now, these transition elements, this is where we find elements like copper, the zinc, the iron. Of course, we know some of those elements there. We found them here. They are found here. Later on, of course, we are going to look at them. We are going to look at them here. Now, let me repeat again here that now how we place our elements here, how we are going to place our elements in this periodic table here, is actually using the atomic numbers. It's actually using the atomic numbers. Now, I want us to place the first 20 elements. The first 20 elements. When I talk about the first 20 elements here, I'm talking about the elements with atomic numbers. Don't forget, I mentioned about the atomic numbers here. The atomic numbers here, I refer to the number of protons in the nucleus of that particular atom there. And therefore, that element whose atomic number is 1 here, that means that its atom has 1 proton. Now, let us have them here. So I'm going to have hydrogen. Hydrogen has 1 proton. That's atomic number 1 here. The atomic number, remember I say the atomic number, the way we place it always, the atomic number should be placed on the bottom left, and the atomic number, the mass number should be on the upper left. Therefore, that's hydrogen. Now, atomic number 2 here is actually helium. You're going to have helium here. That's atomic number 2. Now, atomic number 3 here, of course, we have lithium. Atomic number 4, we are going to have beryllium. Atomic number 5, we are going to have boron. Atomic number 6. Atomic number 6 here, we are going to have carbon. We are going to have carbon here. Now, atomic number 7, we are going to have nitrogen. We are going to have nitrogen here at number 7. Now, atomic number 8, we are going to have oxygen here. Atomic number 9, we are going to have fluorine here. Atomic number 10, I'm going to have neon. Look at that, I'm going to have neon here. Atomic number 11, of course, I'll have sodium. Number 11, I'm going to have sodium. See the way we are arranging them. I get to the first row, the second, I move like that. Now, number 12, I have what? I have magnesium. We are all supposed, we should be able to master the first 20 elements here with the atomic numbers, because this is our scope, most of our scope in our discussion periodic table as far as the high school is concerned. Now, so we're going to have magnesium here with atomic number 12. I'm going to have aluminium here, atomic number 13. I'm going to have a silicon at number 14. I'm going to have phosphorus. At number 15, I'm going to have sulfur. At number 16, I'm going to have chlorine. At number 17, and I'm going to have argon. At number 18, I'm going to have potassium. At number 19, and finally I want to have calcium here at number 20. Look at that. So this is the way we actually arrange. This is the way we are going to arrange our elements in order of their atomic numbers according to Henry. Here, this is just but an advancement of our Professor Henry, who came up with this very idea of using the atomic numbers to arranging the elements in the periodic table according to the atomic numbers. Now, one of the things here that we need to note, one of the things here that I would like us to note is the similarities in the elements found in each of these groups. Something here, we need to understand what is so common in the elements in the same group and the similarity here in the elements in the same period. What is this common feature in each of this? Now, so let's try and look at basically what it means for elements to be in the same group here. What does it mean for elements to be in the same group? Now, for elements to be in the same period. Yeah. Now, let us maybe try to discuss what we just mentioned here about the groups, which happens to be the vertical columns that are in our table. Now, what is so common, for example, if you try to think about group 1, try to look at the elements that are there. We have hydrogen, which is with electron configuration of 1. We have lithium. Now, lithium here is atomic number 3 here, with electron configuration of 2,1. We also have sodium with atomic number 11, and therefore the electron configuration will be 2. There's 2 electrons, of course, occupying the first energy level, 8 in the second. Of course, the last one will have 1. And of course, we're going to have potassium with atomic number 19 here. We have 2, 8. This is 10 plus 8. 10 plus 8 that's 18, and then the 19th one, of course, get into the 4th energy level. Now, I want us to think about this. We can also maybe have, for comparisons, we can have group 2 here. Now, group 2 there, we do have beryllium. Beryllium here with 2,2. With the 2,2, this is atomic number 4. We do have magnesium. Magnesium here with 2,8,2. That's atomic number 12. And finally, we have something like calcium here with 2,8,8,2. That is actually the atomic number 20. The atomic number 20. Now, I want us to see the common thing. What is the common thing about it? We can even have the last one here, maybe, just for comparisons again. Group number 3 here, we have boron with 2, 3, and maybe we have something like aluminium here. We have aluminium, which is a 283. 283, atomic number 13. Look at that. Atomic number 13 and atomic number 5, that is for boron. Now, what is the similarity? I want us to look at that. What is actually the similarity as far as the members of the same group are concerned? Now, if you're trying to look at my electron arrangement here. If you try to look at the electron arrangement, there is something that you can see here. In group 1, hydrogen has 1 electron in the outermost energy level. Lithium here, it has 2, 1. The 1 electron in the outermost energy level. Sodium 281, 1 electron in the outermost energy level. Now 2881 again, 1 electron in the outermost energy level. So what can you tell about members of the same group? Now, members of the same group here will have the same number of electrons in the outermost energy level. And this one, as we shall be seeing in the next lesson here, that this one here, the arrangement of electrons, especially in the electrons in the outermost energy level here, will determine the number of things, will determine the valency. It will also dictate the reactivity of that element. This one will be discussed in the next lesson. Now, to talk about the group 2 again, we are going to have 2 electrons in the outermost energy level, 2 electrons for magnesium again in the outermost energy level with 282 there, calcium 2882 again. We're going to have 2 electrons in the outermost energy level. It goes like that. 3 again, group 3, we're going to have 3 electrons in the outermost energy level. Aluminium there, again, 3 electrons in the outermost energy level. Now, the electrons in the outermost energy level here, we refer to them as valence electrons. We are going to refer to them as valence electrons because they determine the valency of this particular element. They determine the valency of that particular element. Now, so basically, this is about the group here. Some of these groups here are given. They are actually given special names. They are given a special name. Now, the group 1 elements, we are going to call them alkali metals. Those are group 1 elements. Now, group 2 elements, we'll call them, or they will be called alkaline earth metals. We'll call alkaline earth metals. You can see the alkali. Now, these metals here, they will form alkaline solutions in water. Basically because, as we shall see here, when they react with the water, they form hydroxides, and these hydroxides are soluble. We are going to look at that maybe in our further discussions. Now, others maybe that will be given special names. We have something like a group 7. We have group 7 here. Group 7 will be called halogens. Examples of group 7, of course, we have something like chlorine, fluorine here, which is 27. Atomic number 9, we are going to have chlorine here. Atomic number 17, therefore 287. Now, for this ones here, we're going to call them halogens. They are called halogens. This is from the Greek. From Latin one, they're halo, meaning the salt, and gen, meaning producer. We're going to look at that again. They are salt producers. If you take something like chlorine and react it with a metal, you're able to get a salt like sodium chloride, and so on and so forth. Another group here that has special name. Here we have the group O here. The group O here of group 0, and this one comprises of something like neon, which is 28. Again, trying to look at the electrons in the outermost energy level. We do have argon, 288. That's atomic number 18. Atomic number 18 there. You've got to look at that. So in each of these cases, for group 7, the 7 electrons in the outermost energy level. For chlorine, again, 7 electrons in the outermost energy level, and so on and so forth. For neon, again, 8 electrons in the outermost energy level. We have argon, 8. And I just forgot to mention something here, that in group O, we are going to, this one is a special case, maybe I'm going to mention about it. We are going to have the helium with the 2. This one is a special case altogether. This is a special case altogether. Now, one of the things that happens here with what we call the noble gases in group O, we'll be calling them noble gases. One of the things as far as the noble gases is concerned is that the outermost energy level will hold the maximum number of electrons. Now, if we try to look at, for example, neon here, the outermost energy level will hold 8, which is actually the maximum number it can hold. Argon here will have 8 electrons in the outermost energy level, and this is again the maximum number of electrons it can hold. Now, helium again will have 2 electrons, and this one is actually the maximum amount of electrons that can be held by that particular energy level. And then there's the first energy level. That is what we are talking about. That's what we are talking about. Maybe I can mention a few things about what we've just discussed here. Now, elements in the same group. Elements in the same group. So elements in the same group here. In the same group, we'll have the same number. The same number of electrons in the outermost energy level. We have seen that in the outermost energy level. In the outermost energy level. Now, number 2, as far as the members of the same group are concerned here, they have the same valency. They have the same valency. They have the same valency. Group 1 elements, we have a valency of 1. We're going to look at this here simply because they react by losing 1 electron. We are going to look at that. We are actually going to look at that. Group 2 elements will have a valency of 2. Group 3 elements will have a valency of 3. Group 4, we are going to have a valency of 4 again. Group 5, we are going to have a valency of 3. We are going to look at that. We are going to look at that. Group 6, a valency of 2. Group 7, a valency of 1. Now, group 0 do not have a valency. They have a valency of 0. They have a valency of 0 because they have what we call a stable electron configuration. Again, we are going to look at that. Now, for this ones here, they have the same group, and for this reason here, they belong to the same family. Belong to the same family. Belong to the same family. When we talk about grouping elements in terms of their properties, when we talk about trying to group elements in terms of their properties here, our key thing is the group. Members of the same group here will have the same, they will have a similar, they are going to have similar chemical properties. And therefore, we can actually even be able to predict. When I talk about the same group, for example, I can be able to, for example, if I talk about something like lithium, for instance. By the way, I'll also be mentioning something special about this hydrogen here. And if you try to look at it in the periodic table, it has been placed in a special place. It is not connected with these other members. Why is this so? I want to speak it right now. Why this one is so? Because hydrogen can it possesses the property of a metal and a non-metal. Why I'm saying this here is because it can react by losing this 1 electron and can also react by gaining 1 electron. Therefore, it is a special element in the way it reacts. That's why it has also been given a very special position just on the group 1, but basically somewhere special. It is actually not. It does not even have properties really of the alkali metals. I think it's important I mention that. It is important I mention that. So they belong to the same chemical family. Chemical family. Let me just put it that to the chemical family. In other words, the chemical properties. Belong to the same chemical family. That is, the chemical properties of these elements here are similar. They are actually similar. They are actually similar. That is what we are talking about. That is what we are talking about. Let me discuss a few things. Let me mention a few things about the periods. Let me mention about a few things about the periods. Remember, groups here I've talked about these are vertical columns. These are vertical columns. These are vertical columns. These are vertical columns here. Vertical columns. Now let's maybe discuss about the period. Well, now let's look at the periods here, and these are the horizontal rows. The horizontal rows moving from left to right in the periodic table. Now, maybe I can mention something maybe about the period 1, for example. Now, in the period 1 here, the first row, if you're trying to refer to my periodic table here, you realize that we have hydrogen, and hydrogen has an electron configuration of 1. We have just seen this one here. Now, we also have helium with an electron configuration of 2. An electron configuration of 2. For the purposes of comparison, let's look at maybe the period 2. Now, period 2 here, I'm going to have a lithium with the 2-1. This is the first, the second. This is the second row. The second row. Get note of that. I'm going to have beryllium with the 2-2. I'm going to have boron with 2-3. I want us to look at that. I'm going to have carbon with the 2-4. I'm going to have nitrogen with the 2-5. With 2-5, I'm going to have oxygen with the 2-6. I'm going to have fluorine with the 2-7, and I'm going to have neon with 2-8. There are 8 of them. There are actually 8 of them. There are actually 8 of them. There are actually 8 of them. And so far, the fact that we have also already discussed, we have already discussed the groups. You can tell that lithium here is in group 1 because the outermost energy level here has 1 electron here. Beryllium in group 2, beryllium in group 3, carbon in group 4, nitrogen in group 5, oxygen in group 6, fluorine in group 7, and neon in group 0. So this is what we are talking about. Now, basically, and you can actually be able to tell here that actually the members are in a period. In a period, we have elements. We have all groups are represented in a period. All groups are represented in a period. Now, if you go to 3 again, the story would be the same. Maybe for the sake of comparison, why can't we have it here? Now we have sodium 281. 281. Just refer to that. We have sodium. We do have magnesium with the 282. We have aluminium with the 283. We have, you see how it goes here. I have silicon with the 284. I have phosphorus here with the 285. I do have sulfur with the 286. 286. I have chlorine here with the 287. And finally, I have argon. I have argon with 288. That's what we're talking about. Now, if you try to look at maybe this one here, basically what we can actually be able to tell from here. I can actually say here that these periods, as far as the properties are concerned, they may not have a significance. They may not have any significance here. They may not have any significance here. Maybe the only significance maybe in terms of maybe the structure of these atoms. Now in period 1 here, you realize here they have one energy level. One energy level. This one may not be significant as far as the chemical properties are concerned. One energy level. Look at that. Helium and that one there. One energy level. In number 2 there, we are going to have 2 energy levels. 2 energy levels. Again, this one here. When it comes to properties here, we don't have any significance of this. We don't have any significance of this. If you try to look at the members of this here, the members of the same period, they will behave differently. They are going to behave differently here, and therefore there is no significance as far as the properties are concerned, as far as the periods is concerned. And therefore, that's why I said here that we need to be very, very careful when we are talking about the groups. When we are talking about the groups, because this is where now we're going to have the valency. This is where we're going to think about, or we're going to predict about the reactions happening, and so on and so forth. With period 3 here, of course they're going to have 3 energy levels. Look at that. 3 occupied energy levels. 3 occupied energy levels. And therefore, when I talk about a period, here, members of the same period will have the same number of energy levels. Members of the same period, they will have the same number of energy levels. It's also maybe important to mention here that members of the same period here do not have, members of the same period here, or elements in the same period do not have the same chemical properties. Actually, they are totally different. They are totally different here. They are actually totally different. So basically, that is what we're talking about as far as maybe the periods and the groups are concerned. Maybe I can give a question. I can maybe give one question. I can give one question here. Maybe to help us understand what we mean by the word or by the periods and the groups. I can have one question, and then we see what we're talking about. Now, let's have maybe a question, maybe to help us understand what we just talked about. Now, an element is represented as 3919K. In my previous lesson, I did mention here that the subscript here means the superscript, or the number above my element here on your left, represents the mass number, and maybe the bottom one here represents the atomic number. So state the group and period in which K belongs. Now, to be able to do this here, we've got to have the electron configuration. That's the first thing that we're going to have there. Now, the number of electrons here, the number of electrons in an atom equals the number of protons. And the number of protons is actually equal to the atomic number. Therefore, the number of electrons here are 19. Therefore, what will be the electron configuration? So, of course, the first energy level holds 2 electrons. Therefore, I'm going to have 2. The second energy level holds 8. I have 10 electrons now. I'm supposed to represent 19. The third one holds 8. So in total I have 2 plus 8 plus 8 there. I have 18. And the 19th one gets into the outermost energy level, or the 4th energy level. Now from this electron configuration, in which group do this element belong? So as far as the group is concerned, I just look at the outermost energy level and read the number. Now in the group here, the group here therefore will be 1. There's a number of electrons in the outermost energy level. And groups are represented using Roman numbers. Get note of that. Groups are represented using the Roman numbers. Therefore that will be group 1. Now talk about the period. As far as the period is concerned here, I'm just going to look at how many energy levels. How many energy levels does K have? Now potassium will have 1, 2, 3, 4. These are 4 energy levels. Therefore, I'm going to have period 4. please note the way we number them here. These are Roman numbers, these are ordinary numbers here. The numerals 4. Period 4. That's what we are talking about. Now then finally here we have to draw the atomic structure of K. Now to be able to draw the atomic structure of K, I did mention about the nucleus should have the protons and the neutrons. We first of all need to work out the number of neutrons. Now when you're working with the number of neutrons here, you can get it from the mass number minus the number of protons, or the atomic number, which is 19 here. Therefore I'm going to have 20. I'm going to have 20. And therefore of course here I'm just going to have in my nucleus, therefore I'm going to have the 20 neutrons, and I'm also going to have the number of protons here, which is 19. And then I'm going to have, this is my nucleus. That is actually my nucleus. That is actually my nucleus. And of course I'm going to have maybe the first energy level. The first energy level here has 2 electrons. The first energy level has 2 electrons there. I can have 2 there. I can have the second energy level. I'm going to have 8. I'm going to have the third again with 8. The third again with 8. So I'm going to have 1, 2 there. Look at that, that's 2, 8, 8, and finally I'm going to have the last one here, 1. And basically that's what we are talking. That will be the atomic structure of K. That will be the atomic structure of K. So and that marks the end of my lesson 1. In my next lesson here, I will be talking about how do these elements form ions. So kindly subscribe to my channel, share and like, give comments, and I'll be grateful. Thank you very much. We'll meet in the next lesson.